Problem number 3. A point X is selected at random in the interior of a 3, 4, 5 triangle ABC shown below. What is the probability that the area of the triangle ABX will be greater than 3 square centimeters? Alright, so let's get a handle on what this looks like. Alright, so we select some point. Let's just choose this. Alright, and we'll say that point is X. Alright, and so we construct a second triangle here, ABX. Oops, my lines aren't very good there, but so if we construct this other triangle, oops, where'd my pen go? There we go. ABX. Then we need to, we're looking for the cases where this triangle's area is greater than 3 square centimeters. Okay, because we're looking for the probability that the area of ABX is greater than 3 square centimeters. Okay, so let's look at the possibilities for X. In the extreme case, you know, if we happen to choose an X way up here, then the area of ABX is going to be the same or close to ABC, right? And if we choose an X way down here, you know, it's going to be close to 0. So, and so essentially we'll get anything in between the area of ABC and 0, okay, depending on where we choose the X. We're choosing a point at random. So let's look at the case where we have the area of ABX is exactly equal to 3 square centimeters. And that'll be the dividing line between you know, the region where ABX is greater than 3 and less than 3. Okay, so if we find where it's equal exactly to 3 square centimeters, that'll give us sort of our border line. Alright, so let's take a look at the area of a triangle is just 1/2 base times height. So the area of ABX, the base will be 3, right? So we'll have 1/2 times 3, and the height, we'll just call that h, and that'll just be determined by where we choose x. Alright, so we have 1/2 times 3 times h. And if that is exactly equal to 3 square centimeters, then we can find out what h is. So let's multiply both sides by 2, and we get 3h is equal to 6, or h is equal to 2. So anywhere on this line where h is equal to 2, so if they say this is 2 and this is 2, alright, so we divide this leg in half, then any triangle that we draw where the x is on this line, then the h is going to be 2, right, and which is going to give us a ABX triangle with an area of 3 square centimeters. So that's our dividing line between, and anything below, you can see obviously we pick it way down here, the area is 0, or any, you know, if it's over here or over here, it's going to give us something less than 3 square centimeters, and if it's above this line, then it's going to give us something bigger than 3 square centimeters. Alright, so the probability will end up being the area of the desired outcome, I'm going to write it like that, over the total area, okay? So let's compare those areas. So essentially we're looking for the case where x is somewhere in this region, right? Oop, come on, where'd my pen go? My pen disappeared. There we go. Alright, so we're looking for the cases where x is in this part of the triangle. And, you know, the total possible x's would be determined by the area of the whole triangle. The area of the whole triangle is easy to figure out, right? Because 1/2 base times height, 1/2 times 3 times 4 just gives us, what? 6. So this, the denominator will be 6. And the area of the numerator will be the area of the smaller triangle. And you can see that the area is going to be, there's a height of 2, and the base down here, this is the base of that triangle. So we have to figure out what that is. And the thing to recognize is that these two triangles are similar. This smaller triangle up here that I have shaded and the triangle below, they have two angles that are the same. You know, they share this angle, and they both have a 90-degree angle. So that means this angle over here has to be the same as well as this angle, just by the fact that the angles have to sum to 180. And so the sides will be proportional. So if this side is 2, if this side here is 2, right? Because we divide, in order to get an h of 2, we had to divide this leg in half. So if this is 2, which is half of the full triangle, the ABC triangle, then this leg here has to be half of this. So that's 1.5. Alright, so this is 1.5 centimeters, that leg. Alright, so now we can compute 1/2 base times height for the smaller triangle. Okay, so the base is 1.5, 1.5, or 3/2, and the height is going to be 2. Right? So we get 1.5. Alright, so we can write the denominator as 1.5. Now that's, kind of ugly. So I'm going to actually multiply this by 2 over 2. That's just 1. And that will end up giving us 3 over 12. And that can be reduced. So that'll be 1/4. Or 25%, right? 1/4 is the same as 25%. Oops. So that's our answer. There's a 25% chance if we choose any point at random inside this triangle ABC that the triangle formed by ABX will be greater than 3 centimeters. Alright, so there you go.